All right, class, so this is an ALEKS topic that's called simply dilution, and this is definitely a crucial topic as we move forward. So definitely want to make sure that we go over this problem in detail. Now, there are a lot of shortcut methods to do a problem like this, and I would really encourage you to avoid any type of shortcut method for a problem like this. Those will only work in certain scenarios and only if you apply them in the right way. And if you're relying on that, it's just a risk that I would not be willing to take. If you can understand the concept behind this problem, then you'll be able to apply it to any number of problems and always solve these correctly. So no shortcuts. Let's just sort of look at the whole picture, understand the concept behind it, and then start practicing applying it to different situations. Okay, so in this problem, if we want to start breaking it down, we're told that we make this 970 milliliters of this magnesium fluoride solution, and it says working solution. So there's a few terminology things. We might also call this our target solution. You might hear that term thrown around as well. By adding distilled water to 140 milliliters of a stock solution, and we've got this unit of moles per liter. And this stock solution, that's going to be another term that we're going to use. Usually the stock solution is going to be more concentrated, and we're going to be able to dilute it to make whatever we want, whatever other solutions we want. Of magnesium fluoride in water, calculate the concentration of the chemist's working solution or target solution. Round your answer to 3 sig figs. So the first thing I want to talk about is this unit moles per liter. And that is called molarity. So I'm sure we're going to talk about this in class, or we've talked about it in class already, but the unit of molarity is moles per liter, and then we abbreviate that as this big M. So if you ever see this big M, that means molarity, and the unit for that is moles per liter. So that's what this is the molarity of the stock solution that's been given. And then we've got 140 milliliters of that. So if I wanted to sort of draw a little picture to illustrate what's going on in this problem, I'm going to start with 140 milliliters of 0.00176 molar. So I'm just changing this moles per liter to molarity. We're going to interchange those sort of at will of molar stock solution. And then I'm going to add water. So I'm going to put in H2O and dilute. So this is what dilution means. We're going to start with this stock solution and we're going to add more water to make it less concentrated. So we should expect our answer to be less concentrated until we have a total of 970 milliliters of total volume. Now the question is really, what is the molarity of this solution, right? So that's what we're being asked to find. Calculate the concentration, that means molarity, concentration is moles per liter, of the chemist's working solution. Round your answer to 3 sig figs. So if we're looking for the molarity of this target solution, of this working solution, well, we already know the volume. The volume is 970 milliliters. So if I wanted to write out molarity equals moles over volume, moles over liters, then this volume we already know. So what we need to figure out then is, what's the number of moles that are in my solution? Well, that number of moles is going to be based off of the amount of stock solution that I put in. So if I wanted to figure out in this stock solution how many moles are there, what I would do first is I would convert 140 milliliters into liters. And the way that I would like to show that initially, and especially when we're starting out with these types of calculations, is by actually showing that conversion. I know that 1 liter is 1,000 milliliters, so 140 milliliters should be 0.140 liters. We can do that calculation real quick. We can see that our units of milliliters will cancel. Next, I'm going to take 0.140 liters, and I'm going to multiply that by the volume, or by my molarity of my stock solution. So it's 0.00176 moles in every 1 liter, right? That is my concentration of my stock solution. Again, my units of liters will cancel. I'm doing dimensional analysis here. And this is going to tell me the number of moles that I put in to my solution. So that ends up being 2.46 times 10 to the minus, make sure I count my zeros right here, times 10 to the minus 4th moles of MgF2. So this number of moles, that's really what's going to be plugged in, right? So this number of moles, that's what I'm going to plug in here in order to figure out my concentration. So that's going to look like this, 2.46 times 10 to the minus fourth moles over 0.970 liters. So I've already converted this 970 milliliters into liters. And this calculation should give me my final concentration, 2.54 times 10 to the minus fourth molar. So that is the concentration of my new working solution or target solution. So in all of the problems that you're going to get in this dilution section, you're always going to sort of be looking for one missing piece of information. And the thing that you always want to think about is, for each solution that you have, the concentration is moles over liters. The concentration of your target solution will often be lower, right, than your stock solution because you're going to be diluting it. So when we compare our numbers, if I start with this 0.00176 molar, I've diluted it to 970 milliliters. This concentration is now lower. It's a smaller number. That should make sense. But I would just encourage you to understand the concept behind this and then try to apply that to the different situations. If you're still struggling with this and you want me to make another video for certain different situations, I'm happy to do that. But try to wrap your head around what is going on. Why am I doing all the things that I'm doing here?